So slant asymptotes are when we have an asymptote that's a diagonal. So it's not like our vertical or horizontal, it's more of a diagonal line. So one way to figure out if there's a slant asymptote is when the top or the numerator has one more degree than the bottom. Now if you recall horizontal asymptotes, there are three cases. One if they were equal, one if the top was bigger, and then one if the bottom was bigger. So if the top was bigger, we would say that there is no horizontal asymptote. So here, because slant asymptote has to do with the top being bigger, there will be no horizontal asymptotes. So to define the equation of your slant asymptote, you're going to have to use long division. And what we do is we take the bottom and then use it to divide our top. So looking at this first example, it says find the slant asymptote of this function. So x plus 1 is going outside, and then x squared minus x is going on the inside of my function. So to divide it, don't forget you got to add a placeholder for 0. X times what would give you x squared? Well, that would just be x. So x times x is x squared. X times 1 is plus x. So I subtract the 2, and I'm left with negative 2x, and I drop down my 0. So now what times x would give you negative 2x, and that would be negative 2. So I get negative 2, and then negative 2 times 1 is just negative 2. I subtract it, and I get 2. So your slant asymptote is this part right here. So I could say y equals x minus 2 is my slant asymptote. And that's all you have to do. So we just divide it, and that is my slant asymptote. So let's try another one where without a calculator we're going to sketch this function. So first thing, let's find our slant asymptote. So because it's x squared over x, that's how I know it's a slant asymptote. Now I'm going to use long division. So x times x would give me x squared, so I put x there. And I would get, after I subtract them, nothing. So I drop down my negative 2, and nothing goes into that. So negative 2 is my remainder. That means that this top part right here, that is my slant asymptote. So y equals x is my slant asymptote. So if I wanted to sketch that, remember y equals x is that diagonal line that goes through the origin. And with asymptotes, we always do it dotted. So this is my line y equals x. So now, thinking back to 3.5 when we were graphing without a calculator, we need to figure out our y and x intercepts, our vertical asymptote as well. So let's start with vertical asymptote. So vertical asymptote, what I do is I set the denominator equal to 0. So x minus 1 equals 0. That means that x equals 1. That is my vertical asymptote. So I'm going to plot that line x equals 1. And since it's an asymptote, it has to be dotted. Now I need to find my x and y intercepts. So to find my x intercepts, remember we set this whole equation equal to 0. So now I cross multiply. So put 0 over 1, and I get x squared minus x minus 2 equals 0. I can factor that now. So I get x minus 2 times x plus 1. And then I can set each side equal to 0. And that means my x-intercepts are at 2, 0 and negative 1, 0. So again, that was to find your x-intercepts. Now to find y-intercepts, remember you plug in 0 for x. And you use the whole equation. So it's going to be f of 0 equals 0 squared minus 0 minus 2 over 0 minus 1. So when you simplify that, you're going to get 2. That means it crosses the y-axis at 0, 2. And that would be your y-intercept. So now I'm going to plot these points. So 2, 0 is about here. That's negative 1, 0. 2, 0 is over here. And then 0, 2 is up here. So then I would connect your dots. Remember, your graph's always going to go towards your asymptotes as close as it can. So this side's going to look like this, and then this side's going to look like this. So this is my function f of x equals x squared minus x minus 2 over x minus 1. So anytime you need a graph without a calculator and you notice it's a fraction, and the degree on the top is 1 bigger than the degree on the bottom, it's going to be a slant asymptote. So right now I want you to try the next 2 examples, and then I want you to try the practice 1 and 2. So that is your homework for tonight.